Everyone. We are so excited to present our final machine learning project titled Amazon Retail Sales Forecasting and Business Insight Generation. I'm Roshini and this is my teammate Prithvi. Before we dive into technical details, let's quickly talk about why we chose this project. Imagine you're running a store and you suddenly sell off the most popular item. It's frustrating, right? Or even worse, you overstock something that just sits there unsold. That's where demand forecasting becomes really powerful. We wanted to build a practical and interpretable machine learning pipeline that could help answer questions like how much of a product should be in stock tomorrow, when is the best time to run a promotion, which products are silently driving the most revenue. So our project had two main goals. Forecast short-term product demand using real transactional data from Amazon. Second is that extract actionable insights to support smarter retail decision making. So, to build the system, we used a dataset from Kaggle, an Amazon sales report from April 2022. Initially, it had over 120,000 transactions, but of course, not everything in raw data is unusable. Some columns were irrelevant, like unnamed, and some rows had missing or junk data. So we cleaned it by removing unhelpful columns, dropping rows with missing quantities or dates, filtering only the sales that had actually been shipped or delivered. After cleaning, we aggregated the data daily. This gave us 85 days worth of sales volume to work with. This step helped simplify our prediction target while still retaining meaningful patterns. We didn't stop there. We engineered features that a model could really learn from. Features like lag 1, rolling 7, and calendar features like day of week, month, and year to catch periodic effects. We also scaled the data using standard scaler. This step is often overlooked, but it's a super important, especially for models like KNN and SVR, which are very sensitive to magnitude differences. So this visual figure shows a line chart comparing raw versus smooth sales. This includes heat map of a feature of correlation, which is included in the project. With a clean dataset and useful features, we trained 6 different regression models to see which one could best predict the next day's quantity sold. The models we used were linear regression, decision tree, random forest, XGBoost, support vector regression, and KNN. Linear regression was our baseline and was also surprisingly powerful. Decision tree was great for capturing non-linearity. Random forest was a robust ensemble model. XGBoost powerful but sometimes also kills. SVR uses kernel to map data to higher dimensions, and KN relies on historical similarities. We used 80-20 time audit split, meaning we trained on the first 68 days and tested on the remaining 17. This keeps our data honest by not using future data to predict the past. We measure performance using MAE, RMSE, and R square. So the results were linear regression performed best with MAE, which is 119, RMSE it is 165, and R square was 0.55. KN and random forest did okay, but XGBoost actually underperformed, like due to the small dataset size. SVR and decision tree had poor results, including negative R square, meaning they fit worse than a horizontal line. We learned that complex doesn't always mean better. The data had a linear structure and linear regression captured that cleanly.
Top product insights. So once we had a prediction, we turned our attention to product level insights. We aggregated the data by SKU and category to understand what were the 10 products by units sold, what were the top 10 products by total revenue, which categories were consistently performing well. One interesting finding, some SKUs with lower quantity sold still generated more revenue, probably because of higher prices. That's a valuable insight. Top selling is not equal to top earning. This helps businesses focus not just on moving units but maximizing profit. Identify hidden gems, products with greater margins but low visibility. Craft more intelligent promotions or bundles. Shop opening opportunities. We wanted to understand when sales peaked during the week. So we grouped daily sales by weekday and noticed something surprising. Tuesdays, Wednesdays, and Thursdays consistently had the highest sales. That tells us these are great days to launch offers. You can schedule ad campaigns midweek instead of weekends. You might even staff warehouses more efficiently during those days. It challenges the assumption that weekends are always the busiest. Sometimes it's the quiet midweek days that really drive volume. Shop closure signals. Thankfully, we didn't find any zero sale days, which means there were no full outages, but we did identify the 5 lowest performing sales days in April. These low points are golden opportunities to schedule internal system upgrades, run A B tests, do maintenance when customer activity is lowest. If these dips repeat monthly, they might signal seasonal downtime. Businesses can use that insight to fine tune labor costs or rotate stock without disrupting operations. Forecasting future sales. Using our best model, linear regression, we generated a 14-day forecast. Since our engineered features like lag 1 and rolling 7 depend on past values, we extended them using a sliding window approach. We fed predictions back in as inputs for future steps. The forecast curve was remarkably stable, with no sudden jumps or drops. That's a really good sign. It means demand is predictable. Our model is well calibrated. Businesses can plan confidently without fear of major surprises. This kind of forecast can help Amazon or other retailers plan just in time inventory, optimize warehouse usage, and even manage logistics better. Business recommendations. So, what should a retailer do with all this insight? Here are our top 3 business recommendations. First, stock what sells, not just what's popular. Focus on high margin SKUs, not just high volume. Profitability is always greater than popularity. Second, promote midweek, not just weekends. Tuesdays through Thursdays were gold. Leverage those days with email campaigns, app push notifications, or flash deals. Third, use low sale days to experiment. Quiet days are the perfect time for internal tests or backend updates. No disruption is equal to no complaints. We also believe this analysis can go deeper. For example, if we had multiple months of data, we could detect seasonality. We could even try advanced models like Profit or LSTM to predict further out.
To wrap up, we built a full machine learning pipeline from a messy raw data through feature engineering and modeling all the way to real world retail insights. It wasn't just about model accuracy, it was about interpretability, actionability, and business value. We learned that a simple models can outperform complex ones when used thoughtfully, and that even a 1 month dataset can produce rich, actionable insights when explored deeply. We'd like to thank our professor and for their support, and we are happy to get feedbacks throughout the journey. Now, let me show the code for the project.